Welcome back everybody. This is our fifth class in NEET previous year's questions for chapter current electricity of class 12th. Before in this series we have made 4 videos and all of those videos are available on our YouTube channel. There is a dedicated playlist for this type of videos. You can find in that playlist in our YouTube channel's playlist section. Also, we have started similar series for NEET previous years, so you can go. Oh, sorry, JEE previous years. So you can go if some of your friends are preparing for JEE, then you can guide them to that playlist also. And if you want to, you can say get an idea of more slightly difficult questions, then you can also check those question outs. If you like these videos, then do press the like button, share them, and subscribe to as much as possible. And also, if you want to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Now, with this, let's start today's video. And I think we have moved up to around 50. This was the last question which we discussed in the previous video, and today we will start with the next one, that question 53. So let me adjust pen thickness. Let's start. For the circuit shown in the figure, the current I will be. As from the first glance, if we see that both of the batteries are here in series. So suppose this is positive terminal of battery, this is negative, this is positive, and this is negative. So both of batteries are in series, and their positives and negatives align with each other. So we can directly find out that current in the circuit will be total potential 2 plus 1, that is 3, by total resistance, that is 4 plus 2 6. So it comes out to be 0.2 ampere. And if you have doubts regarding this method, then when we go by normal method, so as already mentioned, the direction of current is something like this. So if current flows like this, so this will be positive for resistance and this will be negative. Reaching to the 1 ohm, this will be positive for 1 ohm, this will be negative. For battery, we take their actual, we can say actual signs. So for this battery, this is negative, this is positive. For this resistance, now for this 1 ohm, current will be flowing something like this. So this will be positive, this will be negative, and again for this battery, uh, we will use its actual positive negative signs. Now suppose this is point A. Let's start from point A. So suppose at point A potential is VA. So VA, now we will be moving like anti-clockwise. So positive, negative, and we also we always consider the second sign in the direction. As we enter this resistance, first we encounter positive sign and then we encounter negative sign. So we will be using the second sign, which we encounter while leaving that instrument, or we can say resistance, capacitor, inductor, whatever it is. So this will be negative 4 times I, 4I. Same for this 1 ohm, positive, negative, so negative 1 times I. Now for this battery, we will first encounter negative, then we will encounter positive. So it will be negative to positive, positive 1. For this resistance again, positive to negative minus, so minus I. And again for this negative to positive, we will get 2. And we again reaches to point A. So it is equal to VA. VA get cancelled on the both side, and what we are left with? We are left with minus 4 minus I, so minus 6I plus 1 plus 2, 3 is equal to 0. And from this, I is equal to 3 by 6. It's not 0.2, it's actually 0.5, should be 0.5. So 0.5 ampere. Option D will be the right answer. Moving to the next one. For the circuit given below, Kirchhoff's loop rule for B, C, D, E, B. So B, C, D, E, B. So we have to do calculations for, or we have to apply Kirchhoff's law in this loop given by the equation. So we have to apply Kirchhoff's rule here. Now let's start with point B. As we move from point B, first we encounter this resistance R2, and as per the sign of the current is flowing something like this. So current is going in the right side. So this side will be positive, this side will be negative. Now we have battery, so for battery we take their actual sign, positive, negative, negative, positive, and now we reaches to point E. And for resistance R1, if we see that current is moving downward, so this will be positive for this resistance and this will be negative for this resistance. So now let's apply Kirchhoff's rule. Starting from point B, VB, there will be positive, negative, so negative IR2. Then we have positive, negative, minus E2. Then we have negative, positive means positive, E3. Now coming to point E, we will have I3 going downward. So we will take here direction of I3, and here as per direction of I3 we have negative first and positive second. So negative to positive, positive I3 into R1. Positive I3 into R1 is equal to 0 or not equal to 0. Now we reach again to point B, so is equal to point VB. VB get cancelled and we are left with, you can say, this was I2 actually, minus I2 R2 plus, minus E2 plus E3 plus I3 R1 is equal to 0. So I3 R1 is positive here. Okay, this will be option B. Let's take negative common. So it will be I2 R2 plus E2 minus E3 minus I3 R1 is equal to 0. Option B. Now you may have some doubts here regarding that in this B, C, D, E, in this part current was flowing something like this. But when we reached point E, and we normally assume that current should go something like this, but here current was coming down. So actual direction of current was going down. So it does not matter that what is the direction of current, and there can be multiple currents flowing in a single circuit. But what we assume that in a we can say in a branch or in a one wire, here we have B to E a wire with a resistance R1 connected inside it. In a one branch or in a one wire, when some current is flowing, then we will decide its positive and negative according to that current. As in this case, B to C I2 was flowing, so positive and negative for R2 are decided across according to current I2, and positive and negative for R1 are decided according to the current I3. So that you have to consider and remember that positive negative are decided according to the current, and that those currents can be different in the different branches of the circuit. Now moving to the next question. So potential difference VA minus VB between the points A and B in the given figure is. So as we can see from this arrow, current is flowing something like this. So if current is flowing like this will be positive, this will be negative. Value of current is also given, 2 ampere. For this battery, positive negative will stay the same. For this resistance, as current is flowing something like this from left to right, so it will be positive, it will be negative. Now writing the equation, starting with point A, we have VA, positive to negative, negative, twice into current. Resistance is 2, current is also 2, 2 into 2 4. Now positive negative, so negative 3, positive negative, so negative 1 into current, that is 2, is equal to VB. So VA minus 79 is equal to VB, and VA minus VB is equal to 9. So option D will be the right answer. Moving to the next one. In the circuit shown, the cell A and B have negligible resistance for VA 12 volts. So this is a 12 volts battery. R1 is 500 ohm and R is 100 ohm. The galvanometer shows no deflection. The value of VB is. Now, as mentioned, that galvanometer is showing no deflection. What does it mean? If galvanometer actually works on the principle of current flowing through it. If some current is flowing through galvanometer, it will show deflection. And as no current is flowing through galvanometer, so it means, galvanometer is showing no deflection, means no current is flowing through galvanometer. Now, what will be the condition in which no current is flowing through galvanometer? First, either it is disconnected from the circuit, it's disconnected from circuit, and second condition that we are going to use here, that both of its terminals are at same potential. Suppose we mark 2 points here as point X and point Y. If these 2 points X and Y are at same potential with respect to ground, suppose this is our ground G, because negative of both batteries are connected, so we consider it as a ground point. So if both point X and Y are at same potential with respect to ground, then what will happen? As X and Y are at same potential, so no current will flow from them to X. From X to Y or from Y to X, there will be no current, and that will be the condition for no deflection in the galvanometer. So effectively we can say, as we have to find out value for VB, and value for VB is equal to potential of Y, and we just proved that as galvanometer is showing no deflection, means Y and X are at same potential. So we have as per question, we have to find out potential of this cell VB, that is equal to potential of Y, and that is equal to potential of X. So what we have to find out? Just we have to find out potential at X, and that will be equal to potential of this cell. And as no current is flowing from this part, so what we can do? We can effectively neglect this part of the circuit. We can neglect this part of circuit, and we will be left with this one. So we will redraw the circuit, and our new circuit will be R1 R. Here we have VA. Value of VA is 12 volt. And we have to find out potential at this point X. So for that, current in the circuit will be I, potential by total resistance R1 plus R, so 500 plus 100, 600. This is the current. And now potential drop across this resistance R is equal to potential at point X. So potential drop across this resistance R is equal to potential drop across potential drop across resistance R is equal to potential at X. So VR will be current, that is 12 by 600 times value of this resistance, that R is 100. So it will be 2 volts. So option B will be the right answer. Moving to the next one. In the circuit shown in the figure, the potential at point A is taken to be 0. So it is mentioned that potential at this point is 0. So VA is equal to 0. Then the potential at point B, we have to find out. So now to reach at point B, starting from point A to reach to point B, we have different paths. First, we have this one. Second means first path. Let me write it down. Our first path is moving from A to, I think there are no points mentioned, so let us mention a point here, point E, and also mention a point here, point F. So we start from A, move to E, then D, and then we reach to point B. Second path is ACFB, ACFB, and third path is ACDB. So ACDB. Now we will examine all these three paths, and we'll use the path which is best for us, and for which we have all the variables to solve the question, to solve this condition. And what will be the variables we will be needing to solve this, we can say, this problem. The variables will be, we need to have value of current in that path, and we need to have value of resistance in that path, and we also need to have value of battery if some battery is in that path. Let us find out that how to use these things. Suppose first path AEDB. So from going A to E to D to B, first we encounter a resistance R2 whose value is 1 ohm, and there is a current, downward current, 1 ampere. So we know value of current through R2. So for this resistance R2, everything is okay. We can use this one. Now moving to R1, we don't know value of R1. And nowhere in the statement it is mentioned that value of R1 is something like this. So we don't know value of R1. So we cannot use this path because a detail is missing here. Now moving to suppose ACFB path. Here first we encounter a battery, potential is mentioned, so we know that. Then we encounter a resistance, and this is a unlabeled resistance, means value of this resistance is not known to us. So as this is unlabeled resistance, we don't know its value, we cannot use this path also here. Now going to the last one, that ACDB. So A to C we know value of potential for the battery, it is known. Now coming to the resistance, that is 2 ohm. So value of resistance is known, but we need to have the value of current, and that value of current we can extract from here as A to C there is 1 ampere current, and C to F there is 2 ampere current. So and we have to find current from C to D or D to C. So let's consider point C. For point C, incoming current and outgoing current should be equal. So incoming current at we can say C point is 1 ampere and outgoing current is 2 ampere. So here we have a difference of 1 ampere, and that 1 ampere will be provided by DC. From the D, if there is 1 ampere current downward, so our equation matches that 2 ampere coming and 2 ampere going. So that's how we can balance it. So now we know the resistance and a current flowing through it. And after moving to D to B, we have a battery here, and potential of that battery is also known to us. So ACDB will work for us. Now let assign positive negatives. So this is a battery, so negative positive will stay as it is. Now for this resistance, current is downward, so this will be positive and this will be negative. And this is battery, so positive, negative. Now let's write the equation. Starting with VA, we move first encounter negative, then we encounter positive, so negative, positive, positive of 1. Then we have a resistance negative to positive, so positive twice into current, that is 1. And then we have a battery positive to negative, so negative 2, and then we reach to point B. Now VA is 0, 2 minus 2 0, plus here we have 1 and VB. So VB is equal to 1 volt. Option D will be the right answer. Moving to the next one. Consider the following two statements. Kirchhoff's junction law follows conservation of charge, and loop law conservation of energy. So yes, both are these true, because in junction law what we have total current is conserved. We can say I1 plus I2 is something like I3. Total current in a junction is conserved, or incoming current is equal to outgoing current. And what is incoming current? It is charge per unit time. And what is outgoing current? It is also charge per unit time. So it is a conservation of charge effectively. And what we have now, coming to the Kirchhoff loop law. In Kirchhoff loop law, what we do? We multiply, we just find out potential V, and that is we know that potential is associated with energy. So second is also true. So we can say both are correct. Option D is the right answer. Moving to next one. See the electrical circuit shown in the figure. Which of the following equation are correct for this one? And for this, I think we have to, here we have 3 loops. First, let's add some markings here. A, B, C, D, E, F. So here we have 3 loops for which we can write equations. First one is loop E, D, E, D, C, F, E. C, F, E. This is the first loop. Let's write equation for this loop. And also let's add the current directions. As we can see, I2 is moving something like this, and I1 is something like moving something like this. So both of these will move here, and current in this upper arm will be I1 plus I2. So let's now do write equation for EDCF of the upper loop. Here, for this resistance, current is moving from left to right. So this will be positive, this will be negative. For this resistance R1, current is moving like this. So this will be positive, this will be negative, and for battery, it will be negative, positive. And also for the lower part, as current is moving from left, or we can say right to left. So this will be positive, this will be negative, and for battery, this is negative, this is positive. Now for the upper loop, write equation. Starting from point E, VE, positive, negative, negative. So negative of I1 plus I2 times R. Then we move to this R1, positive to negative, negative. So negative of current through it is I1, I1, R1, negative to positive plus E1 is equal to VE. We again reach to point VE. VE get cancelled, and we have, we can say, E1 minus I1 plus I2 into R minus I1 R1 is equal to 0, and that exactly matches with our option A. Now let's also write equation for the other parts, so that if some other equation matches or not. So for loop, we can say lower part, F C B A F. So let's start from point A, moving clockwise. From point A, first we from point F, first we encounter, we start from point F. First we encounter a battery with positive to negative, so negative E1. Then we encounter negative to positive a resistance with current I1 through it, so positive I1 R1. Then we come down and here we encounter a battery, negative to positive, so positive E2. And then we encounter a resistance, positive to negative, negative of I2 into R2. I2 into R2, and that will be equal to 0. We did not added here a VF because we turn back to same point and these values get cancelled. So we directly wrote like this. And if we compare here, E2, if we write like this, E2 minus, we have here positive, minus I2 R2, and we have minus I1 minus E1 plus I1 R1. So in the second equation, we can say here we have minus I1 R2, but here we have actually minus I2 R2. And also we have a positive sign here, I1 R1, and here negative sign is mentioned. So this is wrong. Now moving to the, we can say, let's make this bigger loop. What is bigger loop? Loop A F E D C B. So we will not be considering this middle wire. We will be only considering the outer wire, the complete outer loop. So here again, starting from point A to F to E, we have nothing, and we reach to this resistance, positive to negative. So negative I1 plus I2 into R, then DCB nothing, and we have E2 here, negative to positive, so positive E2, and then we have positive to negative I2 R2, so negative I2 R2 is equal to 0. So it can be written as E2 minus I2 R2 minus I1 plus I2 into R is equal to 0. And we don't have any equation like this. I think we do have here in the C, but here we have E2 with negative sign. So let's take negative here. So it will be minus E2 plus I2 R2 plus I1 I2 R0. So negative is okay, but we have negative sign here, but as we solved, we are actually getting positive sign. So this is also wrong. And option D is just matching with option A with one change of positive sign here, which we already proved. So from this, option A will be the right answer, which we already solved. Moving to the next one. Kirchhoff's first and second laws of electrical circuits are consequences of energy and what we say, electric charge. So that first law is conservation of charge and second law of conservation of energy. So here option C. conservation of charge and conservation of energy respectively. Moving to next one. First law is conservation of charge. So we have option B. Moving to next one. Choose a correct circuit which can achieve bridge balance. So we have to find that which of these bridges are balanced. Now moving to the option A. As we can see, let me zoom it out slightly. And reduce the pen thickness. So in the option A, we can see here we have a diode, and that is reverse bias. And if diode is reverse bias, its resistance is infinite. So when diode is reverse bias, in ideal condition, its resistance is infinite, and in practical condition, its resistance is very high. So here we have, suppose, reverse bias diode whose we can say inverse resistance is 100 ohm. Practically, it is even more than 100 ohm. It is in thousands. So this bridge will be balanced. So in case we have a bridge and where we have a diode in the reverse bias, so that bridge will never get balanced. Now coming to these two options. So option A is cancelled. Now coming to option C, remaining three options C, B, and D. Now here we have a diode in the forward bias with 5 ohm resistance in parallel with it. Now let's consider to balance this circuit what we have. Suppose final resistance of this one, final resistance of these two in parallel, diode and 5 ohm, is equal to R. So from the balancing equation, 10 by 15 should be equal to 10 by R, and using this, R should be 15 ohm. So their parallel combination should provide us a resistance equal to 15 ohm. And as we know, if we have two resistances in parallel, then their final resistance is always lesser than the lowest possible. So if diode has, suppose, 100 ohm resistance here, but we have a parallel resistance of 5 ohm, then their parallel combination resistor will be less than 5. And if resistance of diode is less than 5, then this will go further down. Let me give an example. Suppose forward resistance of this diode is we can say 100 ohm. Let for consideration, forward resistance is 100 ohm. So their parallel combination will give us 1 by 100 plus 1 by 5, 100 LCM, 1 plus 20, and it will be 20 by 100 by 21 find the resistance, and it will be approximately equal to 5, slightly less than 5. So their parallel combination resistance cannot go beyond 5 because one of resistance is 5, and in case of a parallel combination, combined resistance cannot go above the lowest possible resistance. Considering this resistance is the lowest, 5 ohm is the lowest, so parallel resistance cannot go beyond 5, and it is required to balance the bridge, we require to have final resistance equal to 15 ohm. So this circuit cannot balance because diode and 5 ohm resistance cannot provide 15 ohm resistance in parallel. Now coming to option C. Now here we have 10, 15 and 10, and D 10, 15 and 10. Okay, so these two options are similar, and in this case option C and D, there we can achieve a balance, considering that diode has some forward resistance, and if that forward resistance is 10 ohm, then 10 plus 5 will be 15. So 10 by 15 by 10 by 15, and again same in this. So option C and option D both are right. This might be some type of we can say writing or designing mistake in the question. So according to this, both C and D are right. Option A can't be right because in the reverse bias diode has very large resistance, so it would not be able to balance. And in parallel condition, resistance of the lowest final resistance of both these parallel resistance will be less than the lowest value of the resistance, which is here 5 ohm considering. So they can this diode and 5 ohm resistance cannot provide a 15 ohm resistance as a parallel combination. So hence this option is wrong. So option C and D both are right here. Let's move to next one. The resistance of the four arms P, Q, R and S in a wheatstone are 10, 30, 30, 90 ohm respectively. The EMF and internal resistance of the cell are 7 volt and 5 ohm respectively. Galvanom resistance is 50 ohm. Current drawn from the cell is. So let's first draw the diagram. So we have four arms. One arm has 10 ohm, second has 30 ohm, third has 30, and fourth has 90 ohm. Now we have battery with 7 ohm and 5 ohm potential, 7 ohm potential and 5 ohm internal resistance. 7 volt, 5 ohm, and we have a galvanometer with 50 ohm resistance. So this is internal resistance of galvanometer, and we have galvanometer here, and this is 50 ohm. As we can see from the diagram here easily that 10 by 30 is equal to 30 by 90. So bridge is balanced. So no current will be flowing through galvanometer. So we can easily remove out this galvanometer from the circuit, and our circuit diagram will look like something this. 10 ohm, 30 ohm, 30 ohm, 90 ohm, and here we have 7 volt and 5 ohm. Now 10 and 30 are in series, 30 and 19 are in series, so we can find out their parallel series combination. So circuit will reduce to 10 plus 30 40, and 30 plus 90 120, and battery as it is, internal resistance of battery as it is 7 5. Now 40 and 30 are in parallel, so their parallel combination will give us a resistance of 1 by 40 plus 1 by 20, 1 by 20, 3 plus 1 4 by 120, that is 1 by 30. So it will provide a total resistance of 30 ohm. So circuit will further reduce to 30 ohm, 7 volt, 5 ohm, and now we can find out current from the cell, that I will be, potential is 7 and total resistance is 30 plus 5 35. So 1 by 5 or 0.2 ampere, that is option B. So with this we end this video here. Hopefully whatever we have covered here till now is helpful and understandable to you. Again, if you have any doubts or suggestion, you can put them in comment section. I will try to answer them all and implement. Also, if you like this video, then do press the like button, share it as much as possible, and subscribe to our channel. Your share and subscribe help us a lot. And if you want to donate us something, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any donation, however small it may be, will be quite helpful because it help us to keep on these video making on regular basis. So with this, again, thanks for watching, and we will meet in next video.